So today's pretty easy, and this is going to wrap up this unit for us, even though I have one more section in here, but because of our crazy snow days, we are just going to skip it. It's nothing different. It's another special case, but we've already talked about it a little bit, so I'm not terribly worried. So we're just going to skip it and call it good. Good enough for government work is what we say in the biz. Okay, so right now we are talking about special case lines. These are special lines, and they're too easy is really the problem. But I'm excited to teach you about it because a lot of people don't understand. They just memorize, and if you really learn something, well, you don't have to memorize it. You can just think through it, and that's what I really like. So today we're talking about special lines. We want to be able to graph and write equations of vertical and horizontal lines. We have been using the y equals mx plus b, slope-intercept form. We have the m is the slope, and the b is the y-intercept. And you'll notice there's an x and a y. When we have equations of this form, these lines are like always slanty, okay? They're always at an angle. Sometimes they're very steep, and sometimes they're sort of flatter anyway. But we have some special case lines which are 100% horizontal or 100% vertical. And so to think about this, we want to graph the points on the table. So let's graph these ordered pairs, kind of a review. What do I do to graph the ordered pair, 1, -5? Right 1, down 5. Yeah, right 1, down 1, 2, 3, 4, 5. Starting from the origin. Remember, we're graphing ordered pairs. We got to start at the origin. That's where the doors are. Got to run down the hallway first, and then we can take the elevator up or down. All right, so 1, -2 means right 1, down 2. All right, so I've got 1, -5. I've got 1, -2. 1, 0. That's right 1, don't move anymore. 1, 0. And I've got the point 1, 1, 2, 3, up 4. So 1, 4. So there's our ordered pairs, ladies and gentlemen. What kind of line is this? Straight, up and down. Oh, it has an undefined slope. That's very good. What word is that when it's straight up like that? Vertical. Yeah, this is a vertical line, which is what it says right here below. That's a vertical line. And what do you notice about this vertical line? Like what's this ordered pair? 1, 2. Yeah, And what about this ordered pair? 1, 5. All of these points have something in common. What do they all have in common? They all start with 1. In other words, the x is always 1. Ladies and gentlemen, if the x is always a 1, do you think that's a really good description? An equation that would give you the line where the x coordinate is always 1? It's really specific, actually. The x has to be 1. And in fact, everywhere, Mason, on this line, everywhere, forever, the x is going to be 1. All right? Forever up, the x is going to be 1. And this is the only place that occurs. So a vertical line has the equation where x equals some number. And you notice that the x is the same for every point on the line. And so that number represents the x-intercept right here. The place, the 1 is where we cross the x-axis, but I really like thinking about every ordered pair on the line has an x-coordinate of 1. That's very specific, all right? Let's look at the next graph here. plotting the point -3, -4 would be going left 3, down 4. So here's our ordered pair. -3, -4, -3, -4. Let's see, 1, -4 is right here. 2, -4. And 5, -4 is right here. All right. What kind of line does this one make? Yeah, this is a horizontal line. Horizontal line, it's horizontal like the horizon, okay? Nice horizontal line. What do all of these ordered pairs have in common? They all end in -4. The y coordinate has to be -4. And so for a horizontal line, whatever the y coordinates have to be makes total sense for an equation. Every y coordinate has to equal 4. Because there's not just 4 points on this line that equal a y coordinate of -4. How many points are on this horizontal line? Is it just 4? Well, I could put one there. Now it's 5. Okay, boys. Is there 10? Is there only 10? What about in between? Can I do that? There's a point there, isn't there? Yeah. There's like a million billion. Yeah, absolutely. There's an infinite number here. That's a lot. There's a whole lot of points on this line that all have a y coordinate equal to 4. All right? So that's what I like to think about. If you're ever unsure, you have a picture of a line, and you're like, I don't remember. Should it be x equals or y equals? I don't remember. Well, put some points. Label some ordered pairs and see what matches. All right? And there's your equation right there. If all the y's match, then it's y equals 4. If it's all the x's that match, then it's x equals. All right? Does that make sense to you? All right, let's try a couple here. Write the equation of the line. Write the equation of the line. Anytime you have an equation, you have to have an equal sign and a left and a right side. They have to balance to be an equation. Now, again, I don't want you to memorize stuff. I want you to think it through. So I'm going to go ahead and just label some points here on my line. What is this point here on this line? -4, 1. Let's label a couple more. What's this point? Yep, -4, 4. And this point would be -4, 6. And this point would be -4, 8. All right? What matches? The x. Yeah, remember, these are ordered pairs x, y. And because the x is all the same, we get x equals -4. The x matches on all of those ordered pairs. So that is a perfect equation. X equals -4. Does that make sense to you? Because I don't like you to memorize stuff. I like you to think it through. All right, let's look at number 2. Here's the point right there. What's that point? One, 6. What's next door? 2, 6. What's next door? 3, 6. What's next to that? 4, 6. What's the equation of this line? Y equals 6. Beautiful. Because the y coordinate is in common. Y equals 6. All right, let's look at this line. Again, what are our ordered pairs here? 2, 2, 2, 3, 2, 4, and 2, 5. What's the equation of this line? X equals 2. Very good. Because all the x's have to be 2. And that's how we get that line. All right? Now, once you get really good at this, you can do it faster. But again, I'm writing stuff down for your notes. What's this point here? Three over and down one. All right, 3 negative 1. What's this point? 5 negative 1. And right here would be 7 negative 1. What's the equation of this line? Y equals negative 1. Okay. So really, you know, I love showing that the y is the same for everything. That's the equation then. Makes total sense. All right. Turn the page. What's the equation of this line? Negative 8. What is negative 8? X equals negative 8. Very good. Again, if you labeled a bunch of points, this would be negative 8, 2, negative 8, 3, negative 8, 4, and so on and so forth. Oh, this is a really interesting one. What's the equation of this line? What is 0? Y is equal to 0. Very good. Yeah, kind of weird that y equals 0 is the equation of the x-axis, which is like a total mind warp, like, okay. Very good. Graph the equation. How do you graph y is equal to negative 7? What kind of line is y equals? Horizontal, yeah. I'm going to give you the device that I think about. This is a y, and I can write a y kind of like this. It's a very plain y. If you take that and spin it around, what letter is it? H. H equals a horizontal line, okay? So it's just an upside down y without a tail. But that's how I think about it when I have to go graph one of these things. I think that's kind of an H for horizontal. So a horizontal line through negative 7. 1, 2, 3, 4, 5, 6, negative 7. So here we are on the y-axis at negative 7. We're going to cross the axis horizontally, and there's our graph. X equals, what kind of line is x equals? Vertical line, vertical line. How do I remember that? Well, an X could be formed by 2 little V's. V for vertical. Do you see that? Yeah? Okay. So that's how I remember, like stupid stuff like that. So this is a vertical line. I need to go to the x-axis at 1, 2, 3, 4. That's my x-intercept, and I want to cross the x-axis. So there's my vertical line through x equals 4. Will you graph 9 and 10? Do 9 and 10. Graph 9 and 10. Good. Good. What you doing there, Blake?
If I get like a bad percent on Delta Math, can I go back and finish it and then get a better grade on it?
Yes.
Okay.
Yeah, you just need to email me that you improved your score.
Is it like this?
Yeah. Good. All right. So x equals negative 3. 1, 2, negative 3 is a vertical line through negative 3 on the x-axis. Y equals 2 is a horizontal line through 2 on the y-axis. So the x and the y tell you what axes to go through, and we want to cross those axes. Okay. Number 11. What is the slope? Ooh, interesting. Of the line y equals 5. What does the line y equals 5 look like? Horizontal. It's like this one. All right. What's the slope of a horizontal line? How much does it go up? None, right? It doesn't go up any. It goes up 0. But it does go over, right? It goes over up 0 over 1, up 0 over 1. What's the slope of a horizontal line? 0. Yeah, it's 0. So what is the slope of the line x equals -2? What kind of line is x equals? A vertical line. Yeah, vertical line. It's a vertical line like this one. What's the slope of a line that looks like this? We had two specials. There's a 0 slope, and what's this one? Undefined. Undefined slope. Undefined slope. All right. What's the slope of the line x equals 0? Undefined. Also, it's a vertical line, so it too has an undefined slope. And these are interesting questions. Which axis? What are they talking about when they're asking which axis? Yeah, we got the x-axis and we have the y-axis on our coordinate planes. So our x and y-axis. Which axis is the line y equals -1 parallel to? Ooh, interesting. The x-axis, yeah. Y equals -1 is a horizontal line, much like this one right here. And it's parallel to the x-axis. So x-axis. All right, and last here, how does the graph y equals 3 differ from y equals 3x? Graph both and explain. So over here, let's graph y equals 3. What does y equals 3 look like? Goes through 3 on the y-axis. So 1, 2, 3 on the y-axis. And is it a vertical line or horizontal line? Horizontal line. So here's our y equals 3 line. What about y equals 3x? How do we graph that line? It's almost what we've been doing, y equals mx plus b plus 0. Very good. There's something missing here. So we can think about it in y equals mx plus b form, but we're missing that thing on the end. So I can put in a placeholder of a plus 0. So now that we've filled in the y equals mx plus b, where do we begin? 0. So we're going to start at 0 on the y-axis, and then what's our slope? Yeah, 3 over 1. I love how you told me it was a fraction. What does 3 over 1 tell me to do? Up 3 and right 1. Up 1, 2, 3 and right 1. And then we get this line, which is a slanty line. So how do the graphs of them differ? They're very different, aren't they? Very different, right? So one has the x. Anything with an x is going to be a slanty line, okay? But if it doesn't, it's going to be just flat horizontally or straight up and down vertically, okay? All right, do you guys have questions for me? Today is a Delta Math.